MyLinkedList class. All right, this will be the class we implement for part 2 of this project. As you can probably tell from the picture, how this class is different from the MyLinkedList class from before is that this class will now have a tail member that points to the end of the list. And each individual link will also have a pointer that points to the link before it. Whereas before, these links only had pointers that pointed to the link after it. All right, step 1 of this project will be to create the MyLink class, which will have the value, a pointer to the link next to it, and a pointer to the link before it. Then step 2 will be to create a MyLinkedList class, which will have a pointer to the head, a pointer to the tail, a size member, a constructor, and the isEmpty function, just like before. Okay. Now, as for the methods that we're going to implement the same methods as before, same names. The only names that are different is first index of and display forward. Before, first index of was simply known as index of, and display forward was simply display list. By the end of this video, it'll be clear why we changed those names. And also, even though we're implementing the same methods as before, that does not mean these methods will be identical to how they were before. A lot of these methods we're going to have to make slight changes to, because now we're going to have to account for the tail member and the previous pointers that are in each individual link. Okay. And then after we implement these, we're also going to implement some new methods called insert last, remove last, get last, last index of, and display backward. Okay. Let's start with insert first. With insert first, there are two cases to worry about: the empty case and the non-empty case. Right? Now, here's why we worry about the empty case. Now, the majority of the time that we use insert first, we're not going to be messing with the tail pointer, because obviously, if you're inserting into the front of the list, that has nothing to do with the tail. The only time that affects the tail is if the list is empty, which in that case, if I'm inserting 40 into an empty list, for example, then now the head and the tail will now point to the same object. So in that case, we would have to modify both the head and the tail members of the list. Okay. Now for the non-empty case. If this is my list and I want to insert 40 in front of it, the first step, of course, will be to create the link, then take the current head, have his previous pointer, which currently points to nothing, and have it point to this new link. Then I'm going to take my new link, have its next pointer point to the current head. Then my head pointer will now point to the new link. All right. Next method, the remove first method. With remove first, there are three special cases we have to worry about. The first case, once again, is the empty case. All right. When the list is empty, there's nothing for remove first to do. We're done. All right. The second special case is when there's only one link in the list. Because remove first only deals with the front of the list, the majority of the time, remove first will not have to interact with the tail member. The only time it'll have to do that is if there is only one link in the list. And that is because removing first in that situation will lead to the head and the tail both being set to null. All right? Then for the final case is the case where we have more than one link in the list. In that case, the link that's currently second in the list is going to become first. So the first step will be to take its previous pointer and set that pointer to null. The final step will be to then make that second link the new head of the list. That'll complete the method, and then once the method is finished, the old head will be destroyed by the garbage collector. Next method, remove, which as before, receives a value as a parameter, searches for it, then removes that value from the list. With this method, there are 5 cases to think about. The first case being the empty list case. Clearly, when the list is empty, there's nothing for the method to do. The other case is when our list is not empty, but the number that we're looking for is not in that list. In that case, remove will iterate through the entire list, not find it, and then simply terminate without having done anything to the list. The third case is when the number we're looking for is right at the front of the list. For this case, rather than write code to remove that first value, I would simply just call the remove first method. Likewise, if the number I want removed just so happens to be at the end of the list, rather than write code to remove that last element, I would simply just call my remove last method, which we will talk about how to implement later on in this video. All right. The fifth and final case is when the number you're looking for is anywhere but the front or the back. In that case, the first step will be to go to the link before it and have its next pointer point to the link after it. Right. Then the second step will be to go to the link after it and have its previous pointer point to the link before it. Right. And that would complete the method. And since no other pointer references the 18, when the method is finished, those objects will be destroyed by the garbage collector. Now, for the remaining methods that we talked about last time, we're not going to illustrate, and here's why. The size method, that's obvious because all that one does is return the size member. And then as for the remaining 5, we're not going to illustrate because they're literally identical to the ones we implemented prior for the last class. They don't change, right? All they do is start from the front and iterate from the front to the back of the list. They don't change anything in the list. So we never have to worry about the previous members or the tail member getting changed. So for that reason, if your methods were done correctly the first time, then you should be able to transfer those definitions over to this new class without making a single change. Then, as for the new methods, again, no need to illustrate these because they are simply mirror methods of methods we've already implemented. Insert last is a mirror method of insert first. Remove last is a mirror method of remove first, so on and so forth. And what I mean by that is, to implement insert last, simply take the code you wrote for insert first, copy and paste it into the definition for insert last, and then swap head with tail. Everywhere you wrote head before, put tail there. And everywhere you put tail before, put head there. Then do the same thing for remove last, get last, last index of, and display backward. After you've completed these 2 classes and you've tested it and you're confident that they work, go ahead and submit them to Google Classroom and you'll be ready for the next project.